Okay, good afternoon, everybody. Thanks to Amit and Nishant for those wonderful patterns that they explained. So now taking it further, before coming here, I was thinking I just had a proxy of myself here, to say today. So anyway, let's start. Today I'm going to discuss about prototype pattern. So I think this word is very common. I think everybody would have heard already. Am I right? Yeah. So before getting into the pattern as such, I would like to define those words that we are going to use while discussing this, and so that we are familiar and connected better. So let's define prototype. Would anybody volunteer to define it? It's a simple definition of a prototype.
A simplified model of the actual system.
Right? Any other definition?
Proof of concept.
Proof of concept, right? I think I got almost all the words. So this is how a standard dictionary defines a prototype. So a prototype is an early sample or a model built to represent a concept, as Arvind said, or a process or to act as a thing to be replicated. So you build a model and replicate it, or you learn from a model. You build it to learn from that. That's the story. Then there's another very important word that we're going to use in this presentation. That's called cloning. So anybody for cloning? No Hindi movie definitions. Exactly. So cloning is a process. It's a process of creating an identical copy of an original. So cloned object is a new object and is not a reference to an already existing object. So that's the main difference. So it's an entirely new object which represents an already existing object. So it has most of the features of this object. So there could be only few states that the cloned object differ to, which will be updated after cloning it. So that's the scenarios of cloning in our object-oriented concept. So for every pattern to be defined, there is a problem statement or a motivation behind it. So as you've seen in all the presentation, we give a different problem and then a solution to it. So the motivation, I'm going to explain using an example here. So this is a graphical editor. Okay. So this actually a general graphical editor has been extended for creating musical score. And Ravi is very happy. So there are some nodes which are represented in icons. So a general graphic editor framework has been taken, and it is supposed to be extended to represent, add scores to the document and add notes to the scores. So the problem statement: build an editor for music scores by customizing a general framework for graphical editors, adding new objects, and represents note, tests, and states. The editor framework may have, as you see, the default editor would have some tools which will help you to create those objects. So that needs to be extended to create the graphical notes, etc., which is pertaining to the music. So then how do you solve this? Now you have already an existing framework that you have to extend it to have a music editor to create scores. So there are standard ways we resolve these problems. Anybody? So the music components are all application specific, but you have a framework which could be of generic specification. I'll attempt. Okay, before I attempt for a solution, let me give the details of what classes exist and how you tailor them. Okay, so the first one is an abstract graphic class which exists, which is it represents graphical components that are nodes and staves, and then you have tool class which will give you tools to create these graphical components. And then the graphic tools is a subclass of tools because there could be different types of tools. One, for example, a rotate tool, add, delete, or erase. So there are multiple tools. Okay. So graphic tool is a subclass of this tool. Now, how does a graphic tool, which is a part of the framework, oh, I'm sorry, how does, maybe I should put this here. So graphic tools is a part of the generic framework. So it has to create objects of the application specific components. So how do we do it? Right? So that's a problem. So these are the two independent class hierarchies. So you need to connect them together. So whenever an object or icon is selected and dragged and dropped to create a new music note, okay, it has to instantiate from the tool has to instantiate from the graphic components. Is the problem statement here? These are the graphic components which are used to build this course. For different types of music scores, there are different components. Okay. The first solution is subclassing. You create subclasses of graphic tools to create respective object of the graphic component. Right? So this is one solution. Could you see? This is how we connect this. Created subclasses of graphic tools, say stab graphic tool, whole node graphic tool, etc., which instantiates the objects of graphic components and returns it. Okay, is this clear? So if you see, the only difference between those graphic tool subclasses are the different types of music objects that it creates. That's the only difference. Everything else remains a common. So is there any drawback with the solution? Do you think the solution is good? See, it achieved the purpose. Okay, I extended the normal standard graphic editor to make it application specific. But there are problems in this solution. Anybody?
The domain is unknown.
Maybe you can.
Too many ranks. Explosion of the inherited silent. Yeah. Too many derived classes.
Too many derived classes. There is no specific functionality in each of these derived classes. Okay. Maybe you can replace with any of your boxes on the network. Okay. So as said, it's too many. You're doing too many subclasses just to create different types of objects. There is no specific functionality added to it, right? So it's similar to the factory problem. Right? So even in the factory or the creator classes, we create subclasses, creator classes for every product class, right? So what is the alternate solution? Well, generally there are only two solutions. One is subclass or composition and aggregation in this whole design pattern. So first we explored subclasses and it turned out to be having a lot of disadvantages. So the other alternative is composition, right? So let's look at composition. How can the framework parameterize the instances of graphic tools by the class of the graphic they are supposed to create? What I'm trying to say is that how can the creator class be made to be aware of which object it has to create? So we need to pass some parameters to the creator class. This is the graphic tools. Then what it will do, it will check, okay, this is the parameter, so I have to create an instance of this particular graphic component. So what we are doing here is, in this kind of composition, we are actually modifying the creator class itself. We are not masking. I mean, any change to the graphic components, you add a new note or a new type of music, you have to come back and make change in the creator class, right? So you're making the creator class aware of the product that it is creating. So that's not a good solution. The normal composition way is not a good solution. So the solution is, you have certain prototypes of each of these music notes, okay, and what does the creator class do is just the creator will be initialized to the appropriate prototype and it clones the corresponding objects. So that's a concept. Just keep in mind, be clear as we go ahead. I just read out. Make graphic tool create a new graphic by copying or cloning an instance of a graphic subclass. So when we create a new graphic tool object, we just ensure that one of its member called prototype would be initialized appropriately to the subclass of the graphic component, which could be half node, whole node, or whatever. So the prototype object will point to half node, whole node based on the requirement. And so the graphic tool keeps cloning the prototype, gives you the required object. So how do we do that? This is the representation. Okay. So the graphic tool is going to contain a member called prototype, which is of type graphics. Okay. And the prototype is initialized to the subclasses of the graphic. That is, so whenever required, it could be pointing to staff, could be pointing to whole node or half node, any of them. Okay. So when a graphic tool is to create a new object, new component, it will just clone the prototype. It will not be aware of what it is pointing. It will just say a prototype clone. So I can go on adding any number of type of music components, okay, without modifying the creator cluster. Is this clear? Any questions on this? Okay. So this has been the motivation on why we would need cloning and why we need a pattern for this. So generally you don't come across this pattern very often. Okay. It's basically used when you construct very complex objects, which are very costly if you create them every time. But the other problems also could be solved like this, mostly with editors. For example, circuit design editors. You will have where user-defined circuits can be designed and they act as prototypes. So anybody can go and create from those user-defined circuits, right? So such scenarios you would use prototype generally. So the intent of this prototype pattern is specify the kinds of object to create using a prototypical instance. See, in this case, the prototype member was a prototypical instance, right? And now, using that prototypical instance, you create new objects. That is by cloning. So, because everything is dealt with the object, it's object. And since we create objects here, it's called creation and pattern. Right? Applicability. In what scenarios this pattern could be applicable? This is the next topic that I will be. So as I explained already, when you are creating complex and time-consuming classes, one example I already gave a circuit, and it could be different models of cars, blueprints. So these are different instances. Then, so when as always, is when the system you want to make it independent of how the products are created and how they needs to be represented. Here, the graphic tools does not know which product I am creating, how it is going to be represented, what is the meaning of that, right? It just creates. That's it. And then also there are runtime objects that are loaded, right, which could act as prototype themselves. So in such scenarios also you can use this pattern. So what I'm trying to say is here, you can create new products on your own. Instead of coding for them specifically, you modify the existing object by changing its properties or by changing the structure and then make it as a prototype at runtime, right? And then keep on cloning those new products that you have created. So you don't have to actually code specifically for them. The only thing is that these new products that you or variants that you created would vary in only certain states. They will not have new additional properties. This is a very the good example of this is again circuits which are built using parts and subparts. Right? You add resistors, you add
I understand part about having an abstract class, right? But where is this cloning coming into the picture? I don't understand that. Why is this cloning a must?
You have to create, the graphic tool's purpose is to create an object of graphic components, right? So how does it create an object without knowing the type of the object? What I need is a graphic tool needs to know what it needs to create, right? Here we are trying to avoid graphic tools from knowing what it has to create.
Can you go back to the class?
Yeah. Yeah, the graphic tool's purpose, I'll just tell you, the graphic tool is the icons that I showed. Here, can you see there are different nodes? Sorry. These are instances of the graphic tool object. Okay. So here, if you want to do this give this behavior to graphic tool actually needs to know which object it has to create. But it has drawbacks if you make it no. You can't extend it. You can't add new types at runtime, right? So what the solution is, you make graphic abstract in the sense it doesn't know what I'm going to create. Okay, just as a dummy. Just I create whatever I'm given to. So the point is to ensure that the prototype member is pointing to the right object, right? So now it has an object which is pointing to an object that it is supposed to create. How does it create? Just clone that object. Otherwise, it has to do a new of say flute or particular note, right? But here, what it just does is prototype clone.
Instead of creating a new object, cloning, how does it help?
Because prototype would take care of creating the respective object. You are masking, right? See, if graphic object has to create an object, it has to write. You have to write the code here, right? Like x is equal to new y, right? So graphic tools will be aware of what product I'm going to create, what I need to initialize. So it's an overhead. So every time you add a new note or anything, any icon there, you have to go and edit in this graphic tool, right? If the requested object is x, create x. If the requested object is y, create y. By applying this pattern of cloning, you are avoiding that. So it need not be changed anytime. You can extend your application specific class. So it's connecting your abstract graphical interface, which is generic, with an application specific interface. So that is during initialization, you can create prototypes of all the music notes that you have, or during runtime you can create, and you can have a prototype manager or something, right, which would initialize.
When you do the cloning of an object, where does it get stored? In the heap or in the stack? Because you have to have a memory space for that. So somewhere you have stored
It's in the heap. It's a proper new object. It will be in a heap. It's a replica, right?
So again you are calling new as a part of object cloning.
Yes.
So
The clone will take care of that. It creates a self copy.
Saving the time. You said it's if the things are very tight and you can go with the cloning.
When you have you built a complex object by adding components to it. Okay, so you start from X, then you add Y, Z, etc. You arrive at a model, right? So now, if you want to create the model again, you have to start from X, Y, Z, right? Instead of that, I just clone this, so everything is taken into care. You don't have to write this complex, right? So.
So this time timeline you were saying it decreases the execution time or development time, as you mentioned just now. That is the development time, but what I believe is execution time, right?
Yeah, it's both.
But not only development time.
It's just a copy. So what happens when you call a clone, right? If assume you're cloning an aggregated object, and it has multiple aggregates of them. So each one. Yeah, but you don't have to do that ifs and checks and everything, right? But once you call a clone on the parent object, it calls the clone on every aggregated
I think
object.
that clone would call the copy constructor of the object and
Object,
create the object. And to create those, set those variables in the class, you might have executed some complex algorithm when the real object was created. But when you clone it, you just call the copy constructor and get
Copy the values.
Copy the values. You don't try to achieve those values by running some complex algorithm.
That's fine.
Who is maintaining the prototype? Who is maintaining?
The editor would maintain that. Before creating the object, it has to, while creating the graphical tool object, it would initialize a prototype, a particular music note. So you have a graphical note instance mapped to a particular note. That's predefined in this case, in this example. So when you initialize the editor, right, it should look the way I showed you in the other diagram. So it would create certain default objects. So there would be multiple graphical tool instances for each type of music component. Say for half note graphic tool, half note full note graphic tool instance like that. So the prototype is naturally initialized to the music component.
At what instance is the
During the
pointer
creation-
change
Sorry?
to a different pointer?
It won't change. See, I'm not talking about having one graphical note instance to point to the different music components. Here, in this example, each graphical component will have its own graphical tool instance. See, you have a tool for creating each component.
Or maybe you should just invent a new toolbar, do something like
If you take the PowerPoint, when you're drawing something paper, how do you do that? So you have one like a where it shows objects. There's a circle, there's a square, and different types. You select that, right? After you select that, what we are going to do? It just creates an image of that type, and you're changing the property of
By
that.
selecting the
So that-
pointer is pointed to.
But in the case of PowerPoint, yes, it can change it. But here again, they're describing only a generic solution. So depending on your application, you change that. By selecting it,
By the subclass
maybe for every graphic object.
the other class.
your main program, you're going to request, I need a prototype of this particular one.
They change that, I want to use this toolbar.
Yeah, it's a library. So you have a library of all the pictures, all type of
If you want to
figures
have
which
it
you're going to
studied,
draw.
you can do a
Same way
study.
here, you can just
relation.
select all
I created
types of
that
music notes which you're going to have, basic ones. And once you
Objects,
select
like
one,
icon
then I
like
know that you're going to use this particular one next.
or you have a manager who manages all this. It's kind of implementation specific, I would say. Okay, adding to it. If you want to have a manager who manages all these association, you can implement that way. Or you can have static instances for each type of object. So again, the same, you can avoid building subclasses. So hierarchy of products are not built. So this is how the structural representation. The participants are client, prototype, and the concrete prototypes. So in our example, who is the client? Graphic tool, exactly. And then the prototype is a graphic object. Concrete prototypes are the nodes.
See, we started the discussion by saying that prototype is a model of something else, the real thing. Right? Here, where is the real thing?
Where is the real thing is? I didn't understand this.
There is a prototype class there, but it's a prototype of which class?
So the one which you get after cloning is the real thing, right?
Yes.
It's a subclass, so all the prototypes, concrete prototype 1 and prototype 2, that's both are prototype sets. So you created a family of classes and then you are creating one of. Here you have a base class and then like, you have subclasses of that. So subclass, like, you're just representing, you're using the same form interface, that's all.
And the real thing is the object which you get after. See, the moment you call it clone, it creates the same object, copy of the same object. So that's the real object, which is going to be used. Now these are just prototypes. So keep this ready so that they can be cloned. But when the clone is the real stuff.
So you can copy your prototype 1 and then another copy of prototype 2, depending on what you really want to make. A clone interface, using that you will say, I need to make a clone of prototype 1, or I need a clone of prototype 2. So they call the copy constructor the clone interface, and then you can create that into those objects. It's just a method how the object is being created. That's more of a clone.
Clones are always used to create duplicates. So that's why it used to become a written container. So here is a written.
Yeah, that's why I said it's not Hindi mode.
Yeah, you're right. Normally the real thing should be real and the clone should be clone. The clone is the real thing.
See, prototypes, like I have XYZ, I want copies of them whenever I want. Okay, so that's all is prototype. Alright, so those XYZ are not actually used. The clones are the ones that are going to be used in the application.
And those clones would be little different from the prototype that you said.
Yeah, it could be. It's application specific again. Like you can reuse it as it is, or you can modify the states by calling an initialize some other function. So this is how they map to in our example. So concrete prototype, start, whole node, half node. So the client. So this is how a client asks prototype to clone itself and then changes. So the important point here is the client must ensure the prototype is initialized to the proper concrete prototype. So the benefits of this whole class, I think we have already discussed. It's similar to the abstract factory and builder. It hides the concrete product from the client, and reduces the number of names client know. So you can add as many application specific classes as you want. Lets a client work with application specific class without any modification. You need not do any modification at the client except registering the new prototype. You don't need to do anything else. So you can add new products, that is, you can create new prototypes at runtime and register. That's the same actually. So by varying structure, I meant is by adding new parts to it. So you clone an object, add a new part, and make it a new prototype. So that's what. Reduce subclasses. The liabilities. So, by using this prototypes, as I think probably we can name ourselves, what are the liabilities? What we need to do to use this pattern? We need to implement a clone, right? So it's a must. But implementing a clone function is very difficult if you are already talking about already existing frameworks, right? It may be very difficult to add a new method which will clone itself, because there could be some objects which will have complex internals and they may not be able to be copied, replicated as such. So it may not be an easy job to make an already existing framework to implement prototype pattern. So that's one liability, and all the elements involved in this prototype would have to implement clone. So that's another overhead, because you have to ensure that it is a complete new representation, not a shallow copy. They're not referring to the same aggregate objects. That's the next thing. So cloning prototype with complex structure usually requires a deep copy, because the clone and the original are different. Okay. So I assume everybody understands shallow copy and deep copy, or you can have a refresh also. This is what is shallow copy. When you create a new object out of an existing object, if you have, if the original object has a reference, the new created object would also be pointing to the same reference, right? So any modification to the cloned object would affect the prototype. So that's the shallow. So you can decide what kind of clone you need. And then the deep copy. So you have your own copies. The clone and the prototype have their own copies. So they are not impacted by any modification to each other. So that's the main concept. Yeah, a shallow copy. So you have object 1, okay, and you have some members x, y, and a pointer member. Okay, that pointer is having an address 1001 and it has a value 30, right? So when you make a new copy of it, okay, it just has a bitwise copy. So what happens is the new object created points to the, if it's the same type, okay, because the value gets copied. And when it comes to the pointer, it copies the same address. So what happens? The new object would refer to the same memory. So any change that to the object would impact object 1. If you change the clone, it will impact the prototype. Right? So in case of deep copy, you have to do a member-wise copy where you allocate a new memory location to the object. If you see the integer pointer and object 2 is referring to a different address called under the folder. Right? So any change made to the object is not good.
So the basic requirement of this prototype runner is every component implements clone and a copy constructor, and the copy constructor has to be
implemented properly. That every member is, the deep copy is implemented. So when parent objects are all that they're containing object, it's called deep copy. Right?
only when the parent is found, it's counted.
So implementation, as we already discussed, there are multiple ways. One is you can have standard prototypes and ensure that when you create a creator, it has a prototype always pointing to the target prototype. Or an application can have a prototype manager itself, okay, to which all the prototypes register. So, right, as in when you create a prototype, you just register, inform the manager that okay, this is a prototype of this type, this value. Okay, so whenever a client wants to create a clone, it will pass the key, finds the corresponding prototype from the prototype manager, and it has a clone. So this kind of implementation. So one is using prototype manager. So when the number of prototypes in the system isn't fixed, keep a registry of available prototype called prototype manager, and client will ask a registry for a prototype before. So again, you have to decide between whether you want a shallow copy versus deep copy. So shallow cloning or deep cloning. Initializing the clone. So as I already said, in some specific application you might be happy just after cloning, but in some application you might have to modify the cloned objects slightly. So you would have to also define an initialize member function. So you, after cloning, you would just call the initialize, so it change with the parameters that you want it to be initialized with, so it just changes the required states. That's about it. This is a sample code, and I could not get any application specific, project specific code for my projects, but just added something for real world again. Not real world. Real world. Main world.
Example, how many prototypes you would have, like one for full node and one for half node, or are there any other possibilities also for prototypes?
As in when you have new type of components, you have to have a prototype. As you said, one for half node, one for full node, and if you can create a variation of half node itself, half node 1 with a high scale like that. So you can have, as I said, objects are the prototypes. So you can create different objects and make them the prototypes.
So my question is, suppose that there is a prototype node and we clone off, we do a cloning for that. So all the cloned objects would be same, or they will be a little different also?
Right. It can be different as you treat the object.
Since I don't understand music, so I don't know how to do it.
No.
Because say I
See, this
take
script has
example
two
of full note.
different components. That's it. Don't bother about half note, full note.
Yeah,
This
because you
A1,
gave
B2.
example of two
Right.
prototypes, so
Right.
I assumed one is for full note, one is for half note. And now for full note, if they start cloning, so if I take suppose the 10 clones, so all those 10 clones will be similar or equally like identical or little different. So I don't
It could be different. After you clone it, it could be different. I mean, you can modify it to make it different.
But then you have to modify it.
Yeah.
It just want it to be same.
When you clone, they would all be the same. If you use the same prototype for clone, if you create clone, you clone an object, modify it, and make that a clone. Make that a prototype, sorry. Then you can have.
So suppose that for prototype one, if there are 10 clones, then I will have to specify these 10 clones. They could be different also. So I'll have to specify some parameter so that they could be different, and based on that they can be initialized. Right?
This is one of the examples where you gaining the example. You can create. It's a maze problem. I think everybody is familiar with the maze problems. So you can create different maze problems, and you have in the maze you can have different kind of components, right? So you can have a simple maze, you can have complex maze by adding different what do you call it, features to it to add thrills to the game. So once you can have so these are the prototypes. Maze prototype factory is the client class. Okay, it is responsible for creating a type of maze that you want. And while creating the maze, you will go on adding components like add a wall, add a room, right? Like that. And these walls could be different types, or the rooms could be of different
Based
types.
on the location or something.
But yeah, as you go on building the maze, you can add different types of components. So you have prototype called maze, prototype for room, right? These are initialized when the maze prototype factory is created. So this is how the constructor of the factory looks. If you see when you call make wall while creating the maze, it calls a clone of the initialized prototype. And this is what I said. If you see the prototype clone for the door, after that you're doing initialize, calling initialize. So you change the properties of the clone object.
Here, when you're calling clone of prototype wall, so if you call it 10 times, then 10 walls will be created. So all those 10 walls will be similar. The only difference will be that where are located. Object, right? That would be right.
Yeah. So this is how you create the maze. So one is a simple factory, simple maze factory. So that is initialized with simple objects like maze, wall, room, door. They don't have any special features. But you can create using the same creator class or abstract factory class, bombed maze game. Okay. So where the walls and rooms are different. A room with a bomb. There's absolutely no change in the class, creator class. So you add, but you can add new types of walls.
So I have to delete an object created in when I delete it on the clone, it is separate object.
They're all separate objects. You have all references to those objects exist. So you can independently go and delete. That's just to classify the door. That's all I have. Thank you. Any other questions? Thank you.
So,